With whoever you need to kind of get that work done. This module is facilitated by Ken and Kaylee again, and this is about structuring TA support. So as you've probably gathered, the TA development program at Minnesota has been running for a long time, has done a lot of work on studying things and building things and structuring things. And so this is sort of some general principles, but maybe an exemplar program for a kind of way of actually highly structured, highly supportive environment for TA professional development and for TA support. So with that, there you go.
Okay, thanks. Yeah, and we will, again, lots of nuts and bolts, more stuff in here than we could possibly go over. So it's up to you what we want to do. And if you want to take a nap, that's fine too. And so, we will also go over all the mistakes, we'll indicate some of the mistakes we made so that maybe you'll use those as abject lessons. So again, the same business. Oops, yeah, there we go. But we want to start just to give you a little different, and because, everyone is tired, so we'll have a video. So we're just going to show a video. And this is a video of actually a famous experiment. It's kind of not an experiment, it's a demonstration of sorts. And it's by Edmunds Deming. Do people know who Edmunds Deming is or was? He's dead now. No. He is, maybe by some sort of a founder of systems engineering, and he's credited with making possible the revival of the Japanese economy after World War II, and then coming back and reviving Detroit's economy when their automobile industry was getting killed by the Japanese. And so this is his interpretation of sort of management of a industry, but it applies to TAs. And I hope it'll be clear when we turn it on and see. Okay. Let's see here. Where's my pointer? Can you see the pointer over there? No, of course not.
You just have to hit escape and then...
Okay, the usual. Whoops, that's not it.
So, who does escape first?
Not it. Okay, the usual technology problem.
So hit escape first. Now.
Try that. So now we can, no, we can't do that first. We have to do this first. And we checked it before. It worked fine before.
I think what we needed to do was click on get it going again.
So then hit the...
Yeah.
And then click.
It won't let you click.
It won't let you.
Your
Yes.
slideshow up there?
You can't. Oh, there it is. There it is. It came back. We don't know why. Magic. Nope, that's not it.
If you hover over it, it might...
There you go. Perfect.
Okay.
I turned off the mic, by the way, so that it wouldn't be going everywhere.
Dr. Deming's role is that of the typical American plant foreman using accepted management techniques.
Do you understand that the continuation of your job depends on your own performance?
Yes.
As long as you make enough fight leads, you'll have jobs. If costs start overrunning revenue, management will close the place down. In other words, your jobs are dependent on your own performance. Have I made it clear, do you think you understand? I'll explain the job. Material comes in the form of a mixture of white and red beads. Your job is to produce white beads. Is that clear? White beads, not red ones. You understand there are two vessels here, that they're rectangles. Are you clear? One is bigger than the other. You understand? Their job will be to grab the larger vessel on the broadside, pour the distance of 8 centimeters in the smaller vessel from the corner, and mix the material. You understand? I kept this in the same plane. You understand gravity? Gravity is dependable and cheap. So that you're not shake, you're not bending around, keep it in the same plane. Gravity will do the work. Then back again, the smaller vessel, in the larger one. And just pour at a distance of 8 centimeters. This is a longer day's work. We'll then produce 50 beads. We have work standards here, 50 per day. You will then take the paddle. Paddle has 50 depressions in it. You'll push it down into the beads, down into the beads. Gentle agitation. Are you watching? You'll then raise the paddle, keep the axis horizontal, tilt it 44 degrees. Any excess bead will roll off. Not purposely made some red beads, so you may see what they look like. You understand? You'll then carry work to inspector number 1. Inspector number 1 will count number of red beads, record it on her paper. Chief inspector will compare the 2 counts of the inspectors. If they disagree, there may be a mistake. If they agree, there may be a mistake. Chief inspector is responsible for the count. Announce the count.
Hand.
That's it. And the word is missed.
Smith.
That's it. All right, proceed.
So this would,
8 centimeters. Don't kill it, keep it in the same plane.
notice the assessment going on
No
here.
big deal day about it. I'm back again. Rapid learner. Tough spot. Grab the paddle on the broadside, 2 fingers down into the bead. Gentle agitation, then no more. Raise it, axis horizontal, 44 degrees, excess roll off. Rapid learner. Carry work to inspector number 1. Then the number 2. And I've decided to put on a numerical goal. Not more than 3 red beads in any work zone. 0 is acceptable, 1, 2, or 3, but not more than 3. We have work standards here, 50 per day, no more, no less. Not more than 3 red beads in a workload. Any questions before we get into production? But if we have more than 3, recorder will record it to go on your record. We have the merit system here. 0.
Okay, let's stop for a minute. So does this remind you of TA training? No? Yes? Okay, so who are the TAs in this? Yeah, the workers. They're the people who are trying to be trained in order to do some well-defined function. It's a well-defined function, clearly described, with the process clearly done, and with an assessment. Okay, and of course the TAs are now going to be held to accountable, thank you, for getting the right number of white beads. And white beads are, of course, the undergraduate student's knowledge. And the red beads, the misknowledge. And so now, do you think that the TAs are going to succeed? Okay, after this great training, I mean, very explicit, very clear training. Let's just watch a little more.
For good performance. We penalize poor performance. All right, we're in production. All they have to do is follow procedures rigidly. No departure, no comment, no question. We'll proceed.
No records were kept during the apprenticeship, but this is production. Now records will be kept. Good performers will be given merit raises. Poor performers will be put on probation. As the audience watched the stage or closed-circuit television, Mike and Leon got off to a bad start. The standard is 3 red beads. They had 8 and 14, and now it's Karen's turn.
Karen, you got a job anywhere. Gentle agitation and no further shaking. Perfect. Excellent technique. As remember, the management stated that unless this 4th day or substantially better than the other days, they would close the place down and sweep it out. But somebody in the management came through with a fantastic suggestion. A new style of management. Magnificent. Instead of closing the place down, they're going to keep it going with the 3 best workers. Our best workers are Mike, Aaron, Bob. Mike, Aaron, Bob. Turned out to be our best workers. We're going to keep the place open for the best workers. Fantastic contribution, man. Now, Leon, Melvin, Paul, we thank you for being such willing workers. You did your best. Thank you very much. Pick up your pay and go by the window. Stay in business for the best workers. No doubt about it. That'll do it. We're going to work 2 shifts. Have to keep up production. 2 shifts. Proceed on the first shift. Keep the place open to the best workers. Fantastic contribution to management. Some companies take the top % of the class. Serves right. Why weren't you doing it all along? Look, if Mike could make 5, anybody could make 5. That should be the limit. Perfectly obvious. No question about it. Proceed, Karen. You know what your job is now.
$11, the Smith.
What happened? All right, Bob. 5th day going to show substantial improvement, real improvement. We have only the best workers on the job.
8, the Smiths.
42, 16 makes 58. What happened? 58. Just about the worst day of all. Almost equal to the worst. What happened? I was looking for improvement. Management has decided to close the place down. Thank you very much, Mike. Thank you very much, Karen. Pick up your pay. Willing workers, it goes on the record. You were a willing worker on the red bead.
Here is the first lesson from the red bead experiment. We've said this before, and may very well again. It's important. Being a willing worker, doing your best, trying your hardest, simply are not enough. None of that by itself produces quality.
Okay, so what was the most important lesson or lessons from this as applied to TA training? Yes.
If you don't have the right infrastructure in place, it doesn't matter how much effort and how much work you put into it, it's just not going to be successful.
Okay, so if you don't have the right infrastructure, doesn't matter how hard you try and how willing you are, you're not going to be successful. Another, yeah. Here.
Well, it seemed like the management didn't seem to be clued into really like the process that really needed to be done in order to accomplish the job.
Okay, any other statements? Was the job even possible? Okay, possible but not probable. We're all scientists here, yeah. So, this is a lesson in asking people to do things that it really isn't likely they're going to be able to do. And we should approach our TAs with the same frame of mind. That is, are we asking them to do things that they really can't do? And if so, maybe we should close down the company or at least restructure. Or not. Oh, I think it needs to be on the other.
Yeah, the other one.
Sigh. Yeah. Okay, so that's kind of a small introduction to what we're going to talk about. Again, concentrating on the nuts and bolts and with specific examples where we can, which is always, and there'll be way too much to talk about.
Use your mic.
Oh, use my mic, sorry. Okay, so this is a possible agenda. Agendas never go the way you think they are. So let's just kind of start. And the first thing is things you've already done by now is you've decided what your TAs need to be doing, at least in labs from the last thing. So what support do you think your TAs need to accomplish the goals that you've set out for them? So just take a few minutes to think that over and then discuss it with your partners and with the other people in your pod.
Not necessarily rigid. How hard would that be to get So what do we need to provide for the TAs so they can be successful?
What do you need TA support for? Okay, wait. We're having problems interpreting the question. What do you need TA support to accomplish? What is that? In
To
terms
accomplish
of,
your goals, I'm sorry.
Oh, to accomplish our goal.
Yeah. Or what do you need? Yeah, what do you need the TA support to do?
Okay.
To understand why. You see what I'm doing, right? I got it.
Sorry.
Informative feedback.
Well, yeah, when we do an award, for example, we have peer observation in place, and we don't follow peer observation. I'm proud of you. And they're not great enough. Shock. Feedback. Feedback on the product.
I think our pod's a little confused by the question.
Okay,
Can we
I think we
answer the
know-
question? Can we answer another question?
probably, yeah.
Which kind of support we want to provide to our TAs?
Yeah, what do you want, well, what do you want it to do? I mean, the support that you're going to provide, what's the goal of, yeah, what's the goal of the support?
There's another question. What's the goal of providing
Yeah, to be more effective.
Why are we supporting TAs? So they can
Well, like, oh, those goals, right? These? Oh, yeah, okay. All right, so.
Identity,
Grading.
Yeah, so what about the
So not the faculty.
You know what? That'd be great, but I don't think we're there yet.
Okay, but basically, so
60 times 60.
Transparent so that they know what their expectations
And how do you protocol we have in place?
That would give a 4 labs for semester. Because there will be 2 courses. 3 labs, let's say 3 labs.
I think 3 is a bare minimum.
3 labs, so 6 labs.
Yeah, exactly. They have like.
I don't think that 8 Then, but so like, all right.
Let's just call it
Or the RTC.
like allow your TAs to do what you want them to do.
I'm not going to be communication can be CC.
Properly, but
Okay, a little bit.
we also kind of run into an issue at times where the lab region is a different building than our stock room. So, yeah. So that means that do you have
There's something even, I think there's something before that. Like, how do they learn how to do the thing that you want them to be able to do? Yeah, and maybe the practice. And,
This is our 6th. We're always training TAs, but we formalize it and partner with the school, we're official. And that assistance is going to be done. We give them a certificate, evaluation, we have a program, and PIs have started to see that there's value.
share the building?
There's a part, one of the PIs initially most courses that show has been
Spread out.
Certainly money is an articulation of the value. If the department doesn't value something, it certainly won't put money behind it.
No.
What we do priorities is certificates out.
But I think that's where the relevance is coming in, right? This is relevant for your professional development.
Right.
And we are not just training researchers, we're training people.
How much?
I think it seems like establishing expectations and communicating them is important, like first step for all of the programs. You can't hardly hold anybody accountable. Just kind of what happens when you don't have a professional development program. They don't understand what the expectation is. Right? There's a lot of issues that to deal with this. And also like taking inventory and making sure that we return.
Because that's part of what they're using training is to address. I mean, we had, when we first started our formal training, we had a PI who literally requested that we get his students out.
I've always kind of thought it was very yeah, tracking and providing formative feedback, looking and see how they're developing and how they're performing with respect to those expectations, providing formative feedback. This just seems like, and also the expectations need to be realistic. That was the thing that I was trying to drive home, right?
Okay, why don't we stop for a minute? I think people are getting into a discussion, and that's good, to reflect on what it is. Here you've already established some things. Remember when you described your ideal TA? And the question is, can you make an ideal TA? And what is it, if not, or if, what is the role of this support that you're going to provide? And notice we like to use the word support and not training. We think that actually words matter in communicating to people, especially to TAs, and we're not training them. We are actually educating them, and basically we're supporting them. So we try not to use that word, but we do from time to time because it's the way it is. So, okay, so how do you provide, so what can this support do? So the first thing, I mean, you can think about Michelangelo. When people ask Michelangelo how you carve these beautiful statues, and the answer is, well, you just throw away all the rock that's hiding them, and then it emerges. And so is that what we're doing? So anyway, we think about that. And I think the first step that we found is we actually looked at what our TAs could do before we started. This is way back before we started anything. And I went and observed a lot of TAs teaching discussion sections, teaching labs, and there were a lot of things that I saw that the TAs could not do. And it was not, in some sense to us, after a while, it was obvious that the TAs are only undergraduates. They're your seniors a few months later. They're not experienced teachers. Most of them have never taught before. And so they don't have a lot of skills. They have the skills of a senior undergraduate. And so to ask them to get up in front of a room and explain something is actually something they cannot do. That is, when I watched most of our TAs, and our TAs are very good students. I mean, they're very, very good, and they make excellent researchers and professors. But at the beginning, they really couldn't give a presentation where they didn't make a horrible physics mistake within the first 5 minutes. And it went downhill from there. It's not surprising. There's plenty of research on this, of all the misconceptions that our graduates have when they come out of our undergraduate program. And you can think of yourself. I mean, you're honest, all the misconceptions that you started out with, that you learned after years and years of teaching. And so extended explanations and extended showing students solutions to problems and explaining them was something our TAs couldn't do. Could we have tried to train them to do it? We decided that that was too much to ask for the first year of graduate school when they were concerned with passing their courses, passing their written exam, getting into research, blah, blah, blah. So we looked at all the things that TAs had difficulty doing, and we, like the rock and Michelangelo's statues, we chipped it away. And we saw what was left. So what we wanted to do is to avoid TA failure modes. And many people remarked before that we want to promote in the TAs a really good spirit of teaching and thinking that teaching is important. And of course, nobody thinks something's important if they fail at it all the time. And so we wanted to make sure that we could eliminate most, not all, of the possible failure modes that TAs would have for our educational process. Okay, so some of these are some of the things that are failure modes. Okay, so clearly we want to avoid having them do things that we have assessed that they actually can't do. And we want to structure their teaching environment so they'll succeed. And we want the TAs to feel good about what they're doing. So we don't want them to feel like they're being judged all the time. And we don't want to make teaching be some kind of personal attribute, like you need to speak more clearly. You need to write more clearly. This is all your fault because of the actions that you don't know how to do. So we want to avoid that as much as possible and get beyond sort of the surface aspects of teaching and get to the things that really made a difference to see what was possible. And of course, we don't want the TAs to feel isolated and alone. So we want to make them feel part of the community and that they're connected to the whole effort of teaching in the department. So we don't want them to feel like, okay, here's the lab manual, go off and learn how to teach it. And if you can't, you should just go through the experiments more till you figure that out. So that's not something that we wanted to do. And we wanted to connect the TAs in their teaching to the other TAs for emotional and moral support, and also to the faculty. Because one of the isolated parts of a first-year graduate student is they don't have much contact with faculty members in any kind of real way. They kind of take orders. And we wanted to avoid that. We wanted to give them a feeling that they're working with a faculty member. And also the rest of the staff of the department. So they feel like what they're doing is important and it's an integral part of the department and they're going to succeed in it. And so part of this trying to make this work and not feel isolated was one thing we decided pretty early on, that we had to keep the parts that the TAs were doing in sync with what the lecturer was doing. And so the TAs were not supposed to make up for weaknesses in the lecture. Oh, I didn't get to that, and you need that in the lab, so you give a little lecture on it before you do the lab. So we want to get away from that. And so there has to be intimate contact and communication between the lecturers and the TAs. And the discussion sections are synced with the labs and the lectures. So we want to sync all the parts. And of course, we don't want the TAs to feel like cogs in a system. We wanted them to feel like they were actually an important part of the whole system, which included the faculty, included the staff, included everybody. Okay, so one of the things to make them more successful was to reduce their responsibilities, reduce the stuff they had to do so that they could really focus on student learning, which is what success was. So we looked at everything, all these parts of the rock, and we chipped them away. So we arranged things to reduce the number of students the TAs would teach. Not the number of students that we had to teach, and not get more TAs. Those cost money, and we're not allowed to spend extra money to do this. But it's harder to teach a large number of students if you're supposed to attend to their learning, because you have to know who they are and how they're reacting to things. So to do that, what we did is we took our discussion sections, which TAs led, and labs, which TAs led, and stopped specializing them so that we didn't have lab TAs and discussion TAs, but we had a TA that followed the same students, and the same students were in a given discussion section as in a given lab. So the total number of students that TA would have to deal with was just 2 sections, although they were teaching 4 things, 4 sections in the accounting. So, and that also minimizes the prep time, which seems counterintuitive. Often the faculty tell us, we get new faculty all the time, and they have great ideas like, why don't we just have lab TAs and discussion section TAs, so then the TAs only have to prepare for one thing. That is, they're just preparing for the labs or just preparing for the discussion sections. And the answer to that, the TAs always say that's a bad idea, because actually that's more preparation. Because the labs and the discussion sections are all about the same thing. Okay, so we wanted to reduce the amount of grading, so we looked at how much grading is really necessary. And so we looked at lab reports. Are lab reports necessary? We actually decided they were. We wanted students to have practice in writing and articulating what they thought, what their knowledge was of physics. But how many do you have to write in order to get that practice? So instead of writing one every week, which most of you don't do either, but that's what we were doing. We were having students write a lab report every week, and the TAs grade a lab report every week. We just cut it down to 4 for a semester as enough, and maybe 3 is enough. And then how about homework grading? Do we really need to grade homework? Some people have electronic grading that doesn't take any TA time, but if it does, we decided that homework grading was not important. And we've never seen any positive effect of grading homework. Doesn't mean we don't give homework, it's just we don't grade it, we don't collect it. How about lab notebook grading? The lab notebooks that students do. I mean, again, we used to have piles of them that TAs would grade and get back to the students quick. And again, we decided that lab notebooks are important. Journal keeping is important, and the students are not good at it. But grading never helped because the students didn't get any better. So we looked at a different way to do it that didn't involve grading. And we tried to make the TA role clearer, that the TAs were not the judges of the students. They were there to coach the students. And we had to clarify what we mean by a coach. And I think we've talked about that before, that a coach is someone that helps the students do things in the way that the students want to do them. Of course, if that way is not productive, nudging them onto a close but possible way. And that the TA is never a replacement for the lecturer if the lecturer didn't get to something, or for the textbook if the faculty member thinks the textbook's not clear. And the other thing was, who's the TA responsible for? I mean, when they were teaching like 4 lab sections, those 4 lab sections were taken by students from maybe 3 different professors. Okay, and then there was the person in charge of the lab. So we tried to simplify that so that the TA was responsible to only one person. And that would be a single faculty member who was a lecturer. And that was, that of course reduces prep time because you're only preparing for one thing. And it helps the TA form a team with the other TAs that are working for that professor. So TAs only work for a single professor. And then they can establish in this team what their coherent idea is for the class for every week, together with the professor. And we wanted to account properly for TA time, which is difficult for faculty because they forget that prep time is time, and practice time is time, and meeting time is time. And so we accounted for every minute that the TAs expended to teach class. We gave that to the TAs, and we asked them to talk to the mentor TAs if it went over, because faculty are good at asking graduate students to do a little bit extra. And you do a little bit extra, and pretty soon you're just bogged down in a lot of extra work. And TAs, it's hard for them to say no. So time was an important part. Okay, so having decided what we're trying to get rid of in order to give the TAs time to breathe and time to feel good about what they're doing and time to know their students, we wanted to build some structures that would help. So we wanted to make all the new TAs part of a cohort, so they come to the university and they feel like they have these other people who are there and that they're being taken care of and that they're important. And that's what our TA orientation is about. And we want the TAs, the new graduate students, to have close contact, working contact with a faculty member. So the first semester they're working with one faculty member. They meet with them once a week and they discuss what the course is going to do. Not the faculty member just gives them orders. The faculty member, of course, decides what the directionality is going to be for that week, has to tell them what they're doing, what they've done in the past. The TAs who have better knowledge of the students tell the faculty member what the students understand and don't understand, what's going over and what's not. And so there's a real exchange of information, a real team. Okay, and then making sure that the TAs know what the point is, what the goal of the class is. And the goal of the class can be different for different faculty members. I mean, we try to be uniform, but every faculty member has some idea of what their class, even if it's 1 out of 6 big lecture sections for the same class, they might have different goals, and that's okay. And we also wanted to introduce the TAs to the fact that what we're asking them to do is not arbitrary. There's a research backing, and there's data that goes to that. And then we wanted the skills that they needed, you guys listed some that you wanted, we wanted them to practice it before they face students. And we wanted to give them feedback, but we didn't want them to feel like they were being evaluated. We weren't going to count the red beads. So feedback with no evaluation. And to do that, that's one of the reasons that we decided on mentor TAs, because the mentor TA can give them feedback, but they don't report to the faculty unless there's something dangerous going on. And so these are just some examples of things we did. So this extensive orientation before classes began was a way to bring the new TAs into the family of the department. And that was very easy to, quote, sell to the rest of the department. And we also wanted experienced TAs, because about half of our TAs are returning. Half of them go off to research, half of them either come back from research where they didn't have enough money to support them, or they're still TAs. They haven't found a research field yet. And we wanted a short orientation for them to convince them that they were now not the people, the first year TAs, when they were that, they're just trying to keep their head above water. As much as we're trying to reduce the load on them, still a lot of stuff. They have to take their classes, they have to teach their classes, they have to take a written exam, they have to get involved in a research group. There's a whole mess of stuff. And so when they're experienced TAs, all of a sudden all the things, the moving parts that we talked about before, like for grouping, is more natural, and they don't have to really think too much about it. And we wanted to do that and let them know that they were going to be the leaders in these course teams. And then a weekly seminar for the new TAs as they taught. So this was pretty much what we found. Each of these pieces we actually put piece by piece. It didn't fall out full blown. We just had to say, okay, what's going wrong? What do we need to do? Okay, here's a piece that can do that. And so these are, this is not prescriptive. It's just examples of things that one can do. And the mentor TAs were a big part of this whole process. There's some other things we found that was not useful. We found we couldn't outsource some of the things we wanted the TAs to learn. I don't know about your graduate students. Our graduate students actually don't respect anybody who's not a physicist. And so we have at our university some world-class experts on the things we're trying to do. For example, we were doing cooperative grouping. One of the inventors of cooperative grouping is at the University of Minnesota. In fact, two of them are, the Johnson brothers. And we originally brought them in to, quote, give an orientation to the TAs about what was cooperative grouping about and what was back. It did not go over well. I don't know if any of you know about engineering research, education research, but we have Carl Smith at the University of Minnesota. He's one of the founders of engineering education research. And we brought him and most of our students are engineering students. So we brought him in to introduce activities that would be good for our labs that the engineering students would resonate with. And he, if you know him, he's a very dynamic and very entertaining person, and it just did not go over well. So we had to integrate, so we had to basically take in all of these pieces as much as we can and give them to regular faculty to do in physics. This was disappointing to us, but it made it go over better, that there weren't outside people. Of course, there's this. The regular faculty don't necessarily understand the purpose of the TA support. And Kaylee can tell you some stories about that. And so we have to work with the faculty member who is appointed to run this TA support program every year to make sure that they understand what it's about. And we have to make sure, I say make sure, of course we never make sure. But also all the faculty members who are now have these coherent team meetings with the graduate students, they have to know what the course is, what the support is about. And so we wrote a user's manual for faculty teaching introductory courses, which is on your site, which is great and gory detail about here's what we're doing, here's why we're doing it. This will make your life easier if you do it this way. So all of these things were important. And of course, some of this stuff costs money. And so we had to look around at the university for all the money that was possible that we weren't taking advantage of. And we found quite a bit. And so we just didn't leave any money on the table, which helped. For example, we found out quite by accident that the university was paying our TAs 2 weeks before classes began. It was just the schedule of pay that they gave. So it's 2 weeks before this we're being paid. So we said, great, let's just bring them in. Since they're getting paid, they should come in for orientation. And we did that. Yeah?
I have a question.
Here.
Could you please kindly explain that TAs didn't value experts? Like that part, I'm kind of not, I don't understand. Why is that?
I think that our graduate students are pretty arrogant. I mean, it surprised me, but our graduate students do not maybe our graduate students are more arrogant than yours are, but they really don't believe people who are not in their discipline.
How do you know that?
Because of their reaction to what we did when we brought these other people in.
So resistance or?
Resistance and downright hostility.
Okay. So at Purdue, we actually have an MFA professor come in. He's got a master's degree. He does theater. And that is one of the most well-received seminars that we have for TA training.
Well, that's good to know. So
that's just an example.
Yeah, and so your situation might be different, but ours.
I will corroborate this because I mean, even people don't necessarily take me seriously, and I am the person who took all the classes with them. So it's a weird phenomenon. I think it's worse in physics than it is in chemistry.
Yeah, I don't find our students to be arrogant at all.
Yeah, and I think this is my own personal bias. I feel like some of this is just based on how undiverse physics is, because at least in our department it's mostly white guys, and mostly we have a very significant chunk of international students, but other than that, it's almost everyone is pretty much white men, domestic, and so I feel like the lack of different perspectives gets people to think like, oh, we're the best. No one's ever as smart as us.
Yeah, I'm not saying it's good, but it's that was our experience for this. And every time the university had some. What's that?
White guys are a minority.
Minority in our department.
Yeah.
Miami.
It's 65% female.
Yeah.
Hispanic.
Well, because biology doesn't. I don't see this issue in their departments either. So.
Yeah, and this is just an example of us reacting to anything that happened and trying to work around it, whatever it was. Okay, so there's some things we learned from about TA orientation, which is probably not news to anybody in here, and certainly not news to any educator.
So, this document is in our folder, right?
Yes, it's in the folder.
Thank you.
So this is the paradox of it's not just teaching, it's anything. You can't learn something unless you already know how to do it. So you can't teach before you've taught. And that makes sense. You can theoretically get some presentations, but your brain doesn't know where to put them. And once you've started teaching real students, some things make sense. So one of the things we did is we called this TA orientation, meaning at the end of these 2 weeks, we don't expect the TAs to be good teachers because they will still have never seen a student. But we do teach it with exactly the same techniques we expect them to use with their students. And like I said, this is no surprise to anyone. And we wanted to make everything not just research and research papers and a professor sitting up in front of the class like now saying things, but things that had connected to practical experience. And so we wanted to talk about things like running labs, grading, tutoring, things like that. And we wanted to use real student work when we did it. And we had the orientation led by a faculty member, not a PER person, not someone from outside, not a teaching specialist, all of the things we have, which would be fine, but some really standard high energy or condensed matter or AMO, well, we don't have AMO, but physics researcher. And so we did that, but we need people to actually execute the orientation who have real practical experience with students, and that's the mentor TAs. And so they model the teachers, and we also model the mentoring process. So we actually have one mentor TA teach a mock discussion section with the other TAs, and then we have another mentor TA mentor that TA right after with everyone looking on, so they can see it's not a destructive process and they're more comfortable with it. And we grade their TA assignments. So we assign them to do things like reading and things like you've had here. You know, what would you do if, and so on. But these, so we want to grade them because we want them to know what it feels like to be graded, and what the purpose of grading is. But we also want to use whatever they do. So whatever, this is a mistake that's been done sometime, like why not just have them read something and write a report on it? And then we can move on. We don't have to do that again. And that doesn't work. You have to actually use what they did so that they can practically put it into purpose right away. That's
one of the past iterations of the best practices in teaching class, which is the kind of support class that we have, has had a paper where the graduate TAs would read a variety of papers and then write their own paper based off of that. And they have always been a spectacular failure. So that has been something that we've been working on improving over the last semester.
So the main purpose of our TA orientation is to get the TAs comfortable and to get them used to being treated as professionals. They're no longer students in this realm. They're professionals, and we want to treat them as such. And so just like in here, the first thing that we want to let them know is what are the goals? And we, again, let them discuss what should be the goals, reflect on their own undergraduate career, about how this felt to them. And so this is the agenda for the first orientation session. And all of these things, we don't get up here like I am with you and just talk at them. Well, they discuss what the goals should be. And then we talk about what our goals are, because we have to make choices, as you do, about you can't do all the goals, whatever the goals are for your courses. And we discuss why these, why not some others. It's not that they're better. Some of them, it's just you have to make a choice. And we talk about the orientation that's going to come up and who are the students. The undergraduate students, give them some of their tests to look at and see how they did. Have them, the TAs, take the force concept inventory to see how they do relative to how those students do. Things like that. And each of our classes, we have 7 different introductory physics classes that all have different student populations and different curricula and different goals. And so getting them used to that we can have different goals for different classes. And then the idea of deciding what's important to teach. That is, you can't teach everything. You have to decide, and you have to throw away things that are absolutely painful not to do. And we go through what things we've thrown out of our curriculum and why. And not because they're bad, but because you have to have time for what it is you want to do. And so that's the other question. How much is it important to teach? What is coverage all about? And then we do some things about how we teach, cooperative groups, but we go through the other way other people teach, which is different, to get them to know that there's not just one way of teaching. But whenever you're teaching something, you have to decide on one way. And so just what the decisions are. And their roles, again, we keep reinforcing their roles as coaches and what a coach is about. So that's the beginning of TA orientation. And then we spend a lot of time on coaching, both modeling coaching, having them practice coaching. And so that's the main thing we're preparing them for, is to be coaches. And coaching is pretty natural to people. And so it's not hard to get involved in that. And then we let them know that there could be many goals for physics classes, and our primary goal is problem solving. And so what is it about problem solving? And what can they do to encourage that? What if people found out, not just us, but the whole thing? I want to do some of this. And of course, problem solving is decision making. And as you saw in the last session, the labs are really problem solving. Good labs are problem solving. And so you can call them projects or you can call them problems, but they are about making decisions and the metacognition that's necessary to make the decisions. And so that's the things we do, and the use of cognitive apprenticeship, and we deal with that. So we try to, in this orientation, get them used to dealing with all of these things and practicing them. And when we practice them, for instance, if we want to practice cooperative group problem solving with a problem, we can't give them an introductory physics problem because it's not a problem for them. So what we do is give them a graduate written exam problem and have them work in their groups, and we have the mentor TAs go around and coach them. And that's a real problem for them, so they can see how it feels and how they, what coaching looks like in a real situation. We show them a lot of data that we've taken with our students, which we have, that how these things actually do improve student learning. And we do show, this is what we said before, we do give them an introduction to other ways you can do this stuff, that this is not the only way. And then we spend most of the rest of the orientation practicing cognitive apprenticeship with them, teaching the rest of it with them. So we model, the mentor TAs model discussion sections and lab sections. And the TAs are the students, and the mentor TA is the TA. At the same time, we model mentoring, because the other mentor TA then mentors the TA who is modeling this out so that they can see what that looks like. And we do all the practice and discussion section and lab coaching, so they do that. And so they teach their peers a lab section and a discussion section. This takes many, many days to go through all of this. And they get mentored on that. Whoops, what happened here? And then there's a whole bunch of other stuff that goes in orientation that I'm sure you're all familiar with. And unfortunately, this stuff is outsourced to the experts in the university, and it mainly looks like that. That is, the TAs sit there in neat little rows, and somebody gives them a presentation for 45 minutes on each of these things. And that's just the way it is.
Mostly just checkbox ticking. My discussions with the department's undergraduate PGS, that sort of thing. But if anyone ever needs resources on stuff like this, they can always come to the mentor TAs later when they actually have the problem. It's just they need to actually see it at some point.
Oops. So, okay, so having said all this, here's what a typical syllabus looks like for this orientation section. They change every year a little bit, but whoops. We basically start out the first 3 days, Monday, Tuesday, and Wednesday, kind of belong to the department. And so the last thing on Wednesday afternoon is ethics and professional responsibility. And actually that one is not so bad because there are real case studies in it that the students discuss. And then it goes on. You can read here what happens Thursday morning and afternoon, Friday morning and afternoon, Monday morning, Monday afternoon. A lot of peer teaching in this, and a lot of modeling and description and discussions and having them discussion groups. Kind of what you were doing in here is how we sort of run the whole thing. And then it just keeps going. Practice teaching keeps going. And finally, on Friday, after about 7 days of TA orientation from 9 in the morning till about 5 p.m. We have them get ready for their first lab sessions and discussion sections, which we can't do before because the assignments aren't there before that. This is just that. And then that Friday afternoon, this is all the Friday before the Labor Day weekend, you understand. They go and they meet with the professors and the team that they're going to be working with.
I mean, in physics, we have a lot of international students that come usually 1 week late. How do you deal with those?
International students, yes, indeed. Go ahead, Kaylee, because you've been working with the international
so
students.
There's at least for the College of Science and Engineering, which physics falls under, they actually have their own program called CSE Talk, where all the international students actually come a full month early. So they come in at the beginning of August, and they get 2 weeks of, like, essentially how to be a TA in English, how to be a TA in, like, America. What are the cultural norms that you're going to be dealing with? Do some practice micro teachings, and it's covering stuff like pronunciation, or this is a cultural thing, or you write a word differently.
8 more minutes.
Okay. What's your student body look like? What do they expect? Lots of stuff like that, and then 2 weeks into that, we switch over to our orientation, and that's like the Monday, Tuesday before that. What used to be like the graduate written exam, and then we have this. So they come in really early. Yeah, if they have visa issues, they end up getting contacted way early to get their visa issues dealt with, because there are some people who still have them, but we try to get them dealt with really early. So at the worst case scenario, they miss CSE Talk, miss this orientation.
2 quick questions.
Yeah.
When does the fall fall classes start?
The Tuesday after Labor Day.
Tuesday after. And when, so this is like 2 weeks. So the TAs are started to be paid by when? Beginning of August?
Yes.
Yeah.
So they are paid for all this.
Yeah, if they don't come to this, they don't get as much in their stipend.
Yeah.
Oh.
Yeah.
So
this is required.
This is
Same thing with
required.
CSE Talk.
And so the international students are in this whole thing because they've been prepared for it, and the university does a pretty good job of preparing them for that. Any other questions about? Everyone too tired to? I'm tired just looking at this.
This is like a dream come true. I mean, we are at Northeastern, we're not even allowed to ask our TAs to come in a day before the semester starts. So, because they don't get paid. Is that common everywhere?
Yeah, as I said, we first decided to do this when we found that we were actually paying our TAs during this time. We didn't know. Nobody ever asked. And then we said, oh, okay, they should come in. But, we looked in envy at a place like Ohio State, which brought their TAs in the whole summer before they started. And we said, gee, we would like to do something like that, but we can only dig out 2 weeks. So you do what you can with the time that you've got. And after this time, and we could sell this to the department because the department values its graduate students. They may not value what TAs do, but the graduate students are our lifeblood. They're the people who work in the research labs and keep the grants rolling in, and they're the people we send out into the world. And so the idea of stressing the graduate students less by getting them ready and getting them acculturated and familiar with the department was something that I think all faculty agreed with, what they wanted to do. And then we have this seminar once a week for the next 2 semesters. And remember, all this orientation stuff, they have never yet seen an undergraduate student, so they're not really ready to teach. We have prepared them for their first week, and that's it.
Yeah, they essentially come to the class that's the earlier we mentioned the faculty member that would come in and act as a researcher during the orientation and the mentor TAs. We are the same all throughout the entire year. So if anyone ever has any questions or concerns, they can always come to us. And they are always, like we always have the graduate TAs in our class. They can always come talk to us at any point in time, ask us any questions, email us, anything. Depending on where you are in the year, different things happen. So obviously with any teaching, there's a lot of front loading, right? Like you have to know how to do a million things by like the second week. In our case, it's things like how do you proctor an exam, how do you grade an exam, how do you grade a lab report, how do you assign lab reports. All these things have to be done by like the 3rd week. So the first semester is very much just, how do I even do this? What am I doing? How am I doing it? Whereas the spring semester, we come back and we revisit these things, but with a kind of pedagogical view of what feedback am I giving and why am I giving it? Is it useful? How do I know that? Those sorts of questions. Yeah, we also cover some professional development topics, so things like how does teaching influence your future career, those sorts of things.
And then we do support. This is like a half day of TA orientation for the returning students. And they are very important because they provide the leadership for the brand new students. And we try to make sure every instructional team has at least one experienced TA. But they have to be reminded or introduced to how they can mentor the younger TAs, because they were a younger TA before, but now their role is different. They can do all these things that the other TAs are barely hanging on to do, but now they become the leadership. And one of the things that we have difficulty with in our scheme of things is the team meetings with faculty. Most faculty, we thought that would be easy because faculty run research groups with graduate students. And we tell them this is like running a research group. They're just part of your group that's teaching this course. But it turned out to be more difficult than that with faculty. And so we have these experienced TAs, there's at least one in every team, and they're told pretty explicitly that their job is to lead the organization of the teaching teams. So make sure there's an agenda for every meeting. We don't just sit around and chat. That the TAs, the new TAs are asked what's going on and their opinion about what's being taught, and to sort of work everything in. As you can imagine, the new TAs are pretty reticent about doing that if the faculty member isn't on board and just wants to get the meeting over with. So that works out okay.
This is also a great time to solicit feedback about the program, both in orientation and kind of our support class. This is actually, was it yesterday that we got the checklist of like where your program is strong, needs attention. We don't have any set up eliciting feedback other than this one particular situation, which is why we're trying to do that more. But checking in with your older TAs to see what were you prepared for, what did you need to be prepared for more than you weren't, is a great way to just kind of briefly evaluate the success of your program.
So this is the response of a questionnaire after they've gone through this orientation program. Before they've taught. So this is what concerned the TAs coming out. And you can just see what that is. That's one part. There's another part that they come out very concerned about. And another part. So these are the things, even after this orientation, they come out worried about. And we're there to sort of support them and comfort them as they teach students going through this. And then we ask the second year TAs when they come in, the experienced TAs, the next year, what was their impressions of the teaching they did the first year. And so we asked them, these are the things that were very satisfying to the second year TAs. Remember, as first year TAs. So as you can see, a lot of these concerns turned into successes. And they're very happy about this. And we look at that and say, yeah, that's right. That's what we want. But they also have things that frustrated them while they were teaching the first year. And so these are their frustrations. And so this is good feedback for us to work on. Some of it's hard to work on. There's not a lot of cheating that goes on among the undergraduates, but it does concern the TAs a lot, probably more than it should. Well, and this is what the TA workload looks like. And this is what we tell them to hold to. And our average time for a 20-hour per week appointment is 17 hours. And we try to keep pretty rigidly to that. Not every week, because some weeks it's higher when they grade tests and so on. Some weeks it's lower. And so that's, that's a fast overview of what our TA support program looks like. And we have a lot of materials that's in your folders, and we're happy to answer any questions that you have. Okay. Yes.
Okay. Do TAs grade the exams also, or only homeworks and lab works?
They grade the exams. The TAs that are in a course team do everything for that course. So they do all the grading and the teaching. So everything they do is linked to that course. And we think it's very important that the TAs grade the papers of the students, because that's the most important feedback you get when you're teaching, is what the students are actually answering. And so all of our exams are, open form, solve this problem. We look at what they do. And we also work with the TAs on how to grade exams. So when we have an exam, one TA grades all of problem one, another TA grades all of problem two, and so on. They don't just grade their own section. And then the TAs who are grading, they meet with the professor, and we go through a sample of problems about how they would grade them, so that all the TAs can be on the same basis of how they're grading things.
Okay, great. Let's thank Ken and Kaylee for their participation.